Hello everyone, and come on in. Welcome all to tonight's webinar, Getting Started with Blockchain Programming. Let me know if you can hear me okay, and if you can see my screen here. I'll be sharing the slides for tonight. You can also check out the chat where we have a link to the slides if you want to download them or follow along or read back on another day. So my name is Alexandra, and I'm going to be leading your webinar tonight. I'm also the instructor of the blockchain programming course, which we are running this semester. So any questions you have about the course or about the blockchain, then tonight is the perfect night to ask. I'm also the instructor of the Web3 course, which is along similar lines as blockchain programming. So if you have any questions about Web3, then you can ask those as well. So come on in, everybody, and welcome to tonight. Let's dive into the agenda for tonight. First, we'll introduce Lumiwealth and get to know some of you watching live. Then we'll dive into 4 large topics in the blockchain space. So kind of get your feet wet, introducing some broad topics. And then in the actual summer semester, we have 8 weeks together, so we'll learn topics in depth, and we'll also build a lot of projects every week. Tonight, it's like a bird's eye view of a general overview of some of these exciting topics like blockchain, Bitcoin, Ethereum, Solidity, cryptocurrencies, and NFTs. So I'm excited to bring you tonight's webinar and to bring another semester of this course. We've been running it for about a year now, so I'm very happy to be back for another semester. If you have questions anytime, feel free to ask. We will also have time at the end if you want to save your questions, that's fine as well. All right, let's get started by getting to know some of you live on the call tonight. This will help me to tailor the webinar to the live audience. So if we have mostly beginners, then we'll keep everything at a beginner level. But if we have some experienced viewers, then we can talk more experienced, advanced topics. Same thing with the course. Usually my students are complete beginners. So we usually start learning how to code, how to build smart contracts at a very basic level. So if you feel inclined, please drop in the chat, what is your current occupation? Do you know how to code, and how much blockchain experience do you have? This will give me a sense of your prior experience. It's okay if you don't have any experience in these fields. That's usually what I expect, is complete beginners to coding and to blockchain. Also, feel free to let me know your goals for the course. Now, some of my students, they want to get a job in the space. Some of them are just wanting to learn for fun. Some of them want to start their own side project or release their own project, start a company. So that would also be great to know if you like to let me know your goals after the course is finished. All right, we have one message from Wilfred, a web developer with coding experience in web development, but no blockchain experience. All right, happy to hear that. If you're in web development, you might be interested in Web3, which we're also running this semester, which is all about connecting websites to the blockchain. So for myself, my name is Alexandra, and I'll be your instructor once again for another semester of blockchain programming and Web3. I'm also CTO at Mammoth Interactive, where we build out a lot of projects. All right, now we'll also be posting this recording on Circle and on YouTube, so feel free to check out our YouTube channel, and there you can see some prior recordings, some tutorials, interviews, reviews from past students. So I encourage you to check out Lumiwealth on YouTube and subscribe. All right, we also have another commenter, Tito, no experience at all in blockchain or programming, or in blockchain programming. Same thing with Brian. Okay, no problem, everyone. Good to know. That way I can keep things at a basic level for tonight. Now, if you're watching this live, you already know we have a Circle channel. We also have a Discord channel as a secondary space. So feel free to find us on Discord. Anyone can join our circle and our Discord, even if you're not a student. All right, next let's dive into our first topic of the night. Why learn blockchain in the first place? Why did we create this course? And why are we running it again for the summer? Well, the blockchain is a relatively new technology compared to other types of software. So it's a very exciting space to be in as there's more development and the technology evolves very quickly. And just in general, being a new technology, this is a great opportunity to be the first in the space to build certain projects. So that's one reason that we launched this course. And also we see this type of technology, so-called blockchain technology, being used more and more every day across industries. Any industry that uses software or code can connect to blockchain technology. So we see applications across many industries, everything from real estate to shipment tracking to music to video games to websites. And every day we see the implementations, the funding, the hiring, the projects, the technology being evolved more and more. So we see blockchain technology being integrated more and more every month. And it's a very exciting space as there's this rapid development that you can be a part of. Of course, we see cryptocurrencies, NFTs, as the two most popular ways that blockchain has really gotten into the public, into popularity. We'll talk more about those later tonight, but likely you already know a lot about that because it is hyped up in the media so much. But even beyond just the popular projects that you can do with a blockchain, we can do a lot more with the actual technology behind the scenes, with smart contracts, Web3. So in our course, we're going to be showing you some of the popular projects like cryptos, NFTs, but also how you can build more advanced projects for industry cases, especially getting hired as a blockchain programmer where you might have to build a specific software for a business. Or you might want to build your own project that is something like a cryptocurrency or an NFT contract. There's many different applications of what you can do as a blockchain programmer. This type of technology is even called the future of the internet because of Web3 and how this technology can affect web development. So we talked more about that yesterday at last night's webinar. So if you are interested in how the blockchain affects the web, then check out our Web3 course. Another reason to learn about this technology is to make better investments in the space. If you can read the code, if you can understand the applications and how the software works, this gives you a better chance at making intelligent investments because you can actually understand what you're investing in. And there are great job prospects in the field because, as I mentioned before, there's a lot of funding and it's a new technology with a lot of interest and opportunity to save companies on costs. So those are all just a few reasons why we made this course and added it to our curriculum at Lumiwealth. Here at Lumiwealth, we mostly teach courses about the financial space, but we are expanding into other technologies as well, like ChatGPT, AI, blockchain, as these technologies sprout up and accelerate. And we do see a lot of applications of blockchains in the finance space as well. So the two fields are very intertwined. All right. Our next topic of the night is to talk more about what the actual technology is. So hopefully now we're excited about the technology. We have some reasons why we want to learn. Now let's actually go under the hood and start talking about what does this actually mean, a blockchain? What is this technology that we're talking about that has been accelerating and affecting other types of software? A blockchain at its base form is a piece of software, which just means something that was written with code, some process that runs on computers that was written with code in order to run. So a website, an app, a desktop app, all those are also software. So a blockchain is another piece of software. It's the structure of the software and what it does that makes it specifically a blockchain instead of something like a website or an app, because those are different types of software. You can visualize the software in your mind as a chain of blocks, just like the name says, blockchain. Now, it's not physically a chain of blocks, but it's like a metaphor for the data structure behind a blockchain. So pieces of code, they store data, just like how a website shows text, it shows images. Those are all pieces of data. They're pieces of information. Same thing with a blockchain. It stores data in a specific structure of a chain of blocks all connected. When a blockchain first begins, like when Bitcoin was launched in 2008 or Ethereum in 2015, it starts as one block. But every few seconds, depending on the popularity of the blockchain, about every few seconds, new blocks are added to the chain. And all the blocks contain data. This data is information about what's been happening on the blockchain. What coin did someone buy at this time on this specific day? What was the last coin that was created? Did someone transfer some cryptocurrency? Did someone create a smart contract? Did someone interact with a smart contract? Which we'll talk more about coming up next. So all of these blocks, they store information about what has been happening on the blockchain. And so that is the visual metaphor for how the data of a blockchain is stored. And you can go back all the way to the very first block, and you can see what was happening the very first day that a blockchain was created, whether it's Bitcoin, Ethereum, Cardano, Solana, whatever blockchain you're working with. Now, all these different blockchains out there, they do slightly vary. They're created maybe with a new feature or just with a different structure or different ways of cryptography. But essentially, they're all blockchains because they all follow the base structure of this chain of blocks. So that is the visual metaphor for a blockchain. And this chain is designed to be secured with cryptography, which makes it less likely to lose the data or to get fraudulent data in the chain. So that's why we have cryptocurrencies called cryptos, because they have cryptography backing them. And we'll get more into that later. So this chain can never be cut, can never be broken, to maintain the integrity of the history of whatever has happened throughout all time that the blockchain was ever been existing, was ever since it was born. And this helps establish trust that whatever has happened is being recorded in a secure manner, and that the transactions that do happen are less likely to be frauds or sent with fraudulent money or sent from fraudulent accounts when you compare them to a traditional piece of technology. For example, just paying with your credit card. So feel free to drop any questions you might have so far or anytime, because I know I am throwing a lot of information at you about how this technology works. Once we actually start building projects in the summer, this will also help you understand this whole structure behind blockchains, because we will be getting hands-on and actually putting things onto blockchains. Things like cryptocurrencies and different smart contracts, which we'll get more into coming up in the next slides. Now you might be thinking, why would I want to store data in this form of chain of blocks? Well, we already mentioned a couple reasons. The fact that you cannot cut the chain, so there's more reliability and the fact that there is the backing of cryptography, which makes the transactions less likely to be fraudulent. As well, nothing in the blocks can ever be altered, and this also helps to establish trust in the validity of blockchain transactions. So for example, if I decide I want to send some Bitcoin to my friend, well, I cannot go back into the block and change that once I've already sent it, because everything that's added to blockchains is immutable, which means non-mutation cannot be changed. And this is done to, again, make sure the records cannot be erased. Now, of course, I could ask for the coins back and my friend could send them back to me, or if it's a contract, I could trigger the contract to ask it for a refund, to trigger it to get the money back. But I can't actually go into the blockchain and go to the block of that day that I did the transaction, and I cannot just erase it. Once you put something onto the blockchain or interact with it, it gets permanently recorded. And this is, again, to establish the trust, the validity. So if I send you the funds for something, you cannot say that you didn't receive the funds for my purchase, because we can both check the publicly available data of the blockchain to see if the money actually went through. Did the transaction go through on the blockchain? If it did, then that acts as the third party publicly available trust that you can check. So this helps to reduce the amount of instability in transactions and untrustworthy transactions. That's the number one most interesting or important property about blockchains, is that a blockchain establishes trust between parties, like between you and me, or between me and a company that I'm buying from, or me and someone that made a smart contract. The blockchain establishes trust between the parties, usually a buyer and a seller, but it's not always financial transactions. Blockchain establishes the trust without needing any intermediaries. Instead, the blockchain becomes the intermediary that we can trust. For example, if I'm using traditional technology like an online store and I want to buy something, the third party that's involved is whatever you're paying with, like if you're paying with your credit card or PayPal. And of course, these third parties may take their cut for doing their job of helping establish trust between the buyer and the seller. But for blockchains, instead, the intermediary becomes the blockchain itself. So our costs are reduced because we have fewer third parties, especially with very complex and large transactions that typically require a lot of intermediaries like lawyers, banks, to make sure the transaction is valid. The blockchain does a lot of that traditional work for you because of some things we already talked about, and also because it checks the validity of transactions before it actually accepts them. So it will check the funds that are being transferred, the assets that are being transferred, the users, before it actually allows the transaction to go through. This also helps to prevent fraudulent transactions. The technical term or definition for a blockchain is a time-stamped series of immutable transactions. Time-stamped means that every interaction has a date and a time. So you can see who did what and when did they do it. A series is just saying a list, because we have that chain. Those of you that have programming experience can visualize it as a linked list, because we have this list of items that are all linked. The transactions are immutable because you cannot erase them from the blockchain or undo them to take them off. Once they're up, once the transaction goes through the checks, then the transaction is up in a block forever. You cannot go into the block and take it out. You could do more transactions if you wanted to change your mind of to do something else after, like if you bought something and you want to get a refund or you want to resell. But that would just be a secondary action. You would not ever actually erase the first action. And any interaction on a blockchain is technically called a transaction, but it doesn't have to be a purchase. So you'll understand this more when you actually build smart contracts. Currently, the most popular use for blockchains is with buying and selling, especially with cryptos. So because you're working with something with value, that's usually what you assume when you hear transaction. Like if I'm buying a product or a token. However, it actually refers to any interaction on a blockchain. And it's called a transaction because you have to pay for interactions with a small amount of crypto to pay for gas fees that run the blockchain. So that's why they're called transactions. But anytime you alter anything in the blockchain, like if you want to buy a product or run a process, it's called a transaction because everything that's done is recorded and signed with your user address. And this, again, helps establish the trust because everyone can see what accounts are doing and all the data is publicly available. So you cannot do anything invisibly or behind the scenes. Wilfred's asking, why are gas fees so high? Great question. So gas is what we call the fees that run the blockchain. So it's called gas, just like gas would fuel a car. And so depending on the blockchain, the gas fees can vary. Number one, just based on what blockchain you're using. If there is a lot of popularity at a current time or current day, the gas fees will go up because a lot of people are trying to use the blockchain at the same time. Whenever you want to do something on the blockchain, like if I want to publish a contract, which is like an automated process, like my business, to put it up on the blockchain. Well, I actually get put into a wait list because the transactions have to be checked. You're not just throwing them up there. The blockchain will check the transaction of what you want to do. And so you get added to a wait list to be sent through the computer algorithms that check your transaction before they add them to a block. So you have to wait in line until you get to the top of the line, and then your transaction gets added to a block if it's accepted. So when you pay the gas fees, if you pay the minimal gas fees, you get added to the end of the list. If you pay higher gas fees, you get put higher up in the list, so your transaction goes through faster. So if there's a lot of people, like let's say 100,000 people are trying to use Bitcoin right now, they want to do something on Bitcoin. Well, it's a lot of people that want to do something, so it's a long waiting list. So if you want to get higher up in the list, then you have to pay more in the gas fees. And the gas fees are paying for server costs. So if those go up, if there's a lot of interactions that want to be done, that requires more computing power. So therefore, gas fees go up. Now, some blockchains, especially newer ones, are designed specifically to keep gas fees low because the structure of the code behind the blockchain actually can affect gas fees as well. It's all in the code that wrote the blockchain. So there are new blockchains out there that are designed specifically to lower gas fees. And less popular blockchains will also have fewer gas fees, or there'll be lower rates for gas fees. So great question. Let me know if you need any follow-up. Okay, so a blockchain developer can make money off of the gas fees. Let's see. Well, if you want to be part of an existing blockchain, you can make money off of the gas fees because the gas fees are used to reward the computers that are running the blockchain network. So yes, if you designed a blockchain and you were also using one of your computers to run it based on traditional blockchain design, then yes, you can make money if your computer is powering the blockchain. And you could do this with an existing blockchain like Bitcoin or with a new one that you make. So yes, those gas fees are used to pay the computers for doing their job because that's how a blockchain is run. It's run by computers all around the world because when you write code, you have to run it on a computer. The blockchain is not owned by any specific person. Instead, It's run by computers all around the world that anyone can sign up to become one of the computers. Signing up just means connecting to the network. And the reason that people decide to connect their computer to the blockchain is to make that money. Used to be more that you could make, but as you have more computers doing the jobs, there's fewer that you can make in terms of money. But yes, those are used to incentivize people to connect their computers to the blockchain so that they can make money off the gas fees. Otherwise, you cannot run a blockchain because it's code, and you cannot run code on a piece of paper. You have to run code on computers. But something complex like Bitcoin, which is processing a lot of transactions every second, something like that requires a lot of computing power. And computing power is not free. It takes energy. So yes, that's why you can make money by connecting your computer to the blockchain to help the blockchain run. And as the incentive or payment for that, you do get money from the gas fees. Another great question. Hopefully that answered your question about gas fees. Let me know if you need any clarification. All right. So there's a lot more that we could get into about the cryptography behind blockchains, because this network of computers around the world, it keeps the blockchain running, but the whole design of how it runs is actually in the code. So if you wanted to make your own blockchain, you could customize, you could change up the structure of the code to determine different gas fees, different cryptographic techniques for how you're securing data, how you're checking transactions, what transactions you allow to go through. All of that, you can set that in the design of your blockchain. And you can therefore see a lot of new blockchains coming out these days, which boast their new features, like this one's more secure, this one's better for the planet, this one has fewer rates in terms of cheaper gas fees, this one has better proofs, which are referring to computer algorithms that check transactions. This one can handle more transactions at once because of its structure, and therefore it has faster times and fewer fees. So all the time we see new transactions, new blockchains being created, boasting new features, which are all written with code. This all began back in 2008 with Bitcoin, which was the first blockchain that was ever created. And since then, as I mentioned, we get more blockchains being created constantly. One especially notable blockchain was created in 2015 called Ethereum. And in our course, we're actually going to be using Ethereum throughout our 8 weeks. But if you learn how to work with one, then you can easily transition or transfer your skills to another blockchain, because the underlying structure of blockchains and programming languages is the same. So it's very transferable skills. So Bitcoin is currently the most popular blockchain, and Ethereum is number 2. Now you might be thinking, why didn't we just pick Bitcoin for this course? Well, we actually picked Ethereum because it was designed to improve and expand the features of Bitcoin. So Bitcoin was very revolutionary back in 2008 because with it came the invention of blockchains and cryptocurrencies, with Bitcoin, the first cryptocurrency. Ethereum was also revolutionary, however, because it invented smart contracts, which allow for much more complex processes to run on blockchain technology. Because Bitcoin is primarily just for using and buying, selling Bitcoin cryptocurrency. But with Ethereum, the whole idea or point of Ethereum was to expand what was possible with blockchain technology beyond just cryptos, but actually also allow any process written with code to be run over blockchain technology. So instead of just storing information about, who bought and sold Bitcoin in the blocks, we can store information like who bought other products that are connected to tokens, which represent assets, or who is interacting with a business process that lives on the blockchain. Traditionally, we never had this type of decentralized technology where there's no central owner, but instead it's this network of computers running this chain of blocks, this ever-growing chain of blocks. But with Ethereum, we essentially took Bitcoin and expanded what was possible, so a lot more complex code can be put onto the blockchain and stored in the blocks. It's not possible with Bitcoin. Bitcoin allows for simple scripts to be written, but those are limited in terms of the kinds of algorithms and code and business processes that you can put. So that's why we chose Ethereum for this course. Which brings me to our next topic, smart contracts, which were invented in 2015 with the invention of Ethereum. And Ethereum uses a coding language called Solidity to write the smart contracts. Because you cannot write the contracts in English, you have to write them in a coding language so that the code can be run on computing power. So just like we would write a book in English, we would write a smart contract in Solidity. So we will be learning how to code from scratch in our summer semester. We'll be learning how to code specifically in Solidity through smart contracts. And luckily, coding is a transferable skill. So if you learn one language, it makes it much easier to pick up another coding language. So don't worry, if you have no experience in coding, you can still sign up. We will be learning from the basics from scratch. If you do have experience with programming, this will give you a leg up because you'll be able to understand the programming faster. So throughout our summer semester, we will be building tons of smart contracts. Now, what are these smart contracts? Well, it's called a contract because it's like an agreement, like a traditional contract. For example, if you get hired for a new job, you might sign a job contract. Or if you're buying a house, you might sign a house contract for the purchase. And this is to perform an agreement that if you do something, you'll get something in return. For example, if you get hired, then you'll abide by the rules of the job, and you'll also get payment for your work. Or if you send the money for the home, you'll get the ownership rights to the home. A smart contract follows this same kind of idea where you are writing an agreement for something that will happen. And you have to write it in code to outline exactly what is possible in your agreement. And it's called a smart contract because it's written with code, kind of like a smartphone. So what kinds of contracts might we write? Well, thanks to Ethereum, possibilities are endless for the kinds of contracts you can create. We see lots of examples of financial contracts, but also across industries. For example, I can write a smart contract to represent an online school. And in the contract, I can allow for payments so that students can sign up for a course if they pay. And in return, I can send them the access to the school. So that's just one example. Another example could be an online shop where kind of the same thing as a school. The customers this time will send you payments and you'll send them some ownership or rights to some product or access to a product. Another example could be a financial instrument, like a loan system where users can come and they can trigger your contract to take out a loan in the form of cryptocurrencies. And then they can use that cryptocurrency, but they have to pay back the loan with interest. Another example is a bank where you write a contract where your clients or customers can create new accounts. These accounts will be stored on the blockchain and users can deposit and withdraw funds from your bank. So all these processes that run are written as smart contracts. So in the contract, you say exactly what can happen, who can do what, like what are the rules of your bank? Can your bank do deposits and withdrawals or can it do loans as well? Can it do long-term savings? So in your contract, you define exactly what your system can do. Okay, we also have some questions from Wilfred. Which other programming languages is Solidity similar to? Solidity is most similar to JavaScript. So if you have experience with JavaScript, then you'll notice it looks similar. Not exactly the same. There are some key differences, especially when coding for the blockchain. But yes, Solidity is similar in how it looks to JavaScript. We also have a question from Tito. Are NFTs a type of smart contract? Yes, that is right. If you want to build out your own NFT, you can write a smart contract for it. The contract defines the NFT, what it can do. Is it just for storing names of the tokens? Or does it allow for storing media like images? How many times can each token be transferred? Does the token change over time? What kind of asset is it representing? Is it just representing purely media, or is it actually linked to some real world asset? So yes, an NFT is one example of a smart contract. And there are many other types of examples as well. For example, if I wanted to track my shipping, if I'm running a business that does shipments, I can write out the process in my smart contract and then track all the steps that are written out in the contract. One reason to do that is to prevent loss of data, especially if you frequently have gaps or steps that go missing during a complex process, because it's much harder to lose data that's stored on the blockchain for lots of reasons that we already mentioned. Like, for example, the fact that you can never break the chain or take anything off. Any piece of traditional software can be written into a smart contract form. So traditional software would just be any other type of code, like if you have your own website or a mobile app, you can connect it to the blockchain, or you can just put the processes onto the blockchain in the form of a contract. So in our course, we'll be building tons of examples of smart contracts. So we see a lot of this type of connection across industries because any type of traditional software can connect to the blockchain. Any business can make a smart contract to take advantage of the benefits of decentralized technology. Lots that we already mentioned, like access to crypto and the validation, the cryptography, less chance of fraudulent transactions, the trust established without third parties, as well as the autonomous features of smart contracts. So these contracts, they run on their own. Once you publish a contract onto a blockchain, depending on the blockchain, but usually you cannot alter it or even have any more changes done to it. Now, you could establish your account as having special features of what it can access in the contract. If you want it to be like the administrator, you can define different roles in your contract, like you have managers, administrators that have access to more features than just your customers. But in terms of actually editing the contract, you cannot actually go in and change the contract. And this is to establish trust with your user base. So it's kind of like when you write a contract and you sign it traditionally, like for a job. If I sign a contract that establishes my salary, I don't want the other party to just be able to change the salary at any point. You know, I want to have trust that the salary that I see written will not change in the future. It's the same idea here. When you write a contract and you publish it, it's immutable. And that is to establish trust between both parties so that your customers can be rest assured that your contract's not just going to disappear or change or suddenly change the price at any point, because the code shows exactly what will happen. Anyone can go to the blockchain right now and see every single contract and what it does, what the code is behind it, and they can check will it actually give them what they say it will? For example, if your contract is selling tokens of representation of real estate, you can go in and see if you send the crypto, will you actually get the ownership of the tokens that you're promised? Okay, we also see Wilfred asking, how would I be able to view a website on a smart contract? All right, so there's different ways to connect websites to smart contracts. Number one way would be just to write your web functionality in smart contract form. So let's say you have a website like an online store. Traditionally, we have the front end and the back end of the site. So we have the web page itself that your customers see. We have the back end of the server, the database storing the data about your online store and actually doing the work of taking payments from people's credit card, their PayPal, and then sending them the product through your online store. Now, with a smart contract, you can take that functionality and you can write it in smart contract form. So in your contract, you will write with Solidity that users can send you crypto and you will send them products in return. This could just purely be a smart contract on the blockchain, but you can also connect it to the actual web page that you have published now. And this is done with Web3, which we actually have another course about called Web3 that it will also be running in the summer. So this kind of connection is done with code, where websites can actually show the data, the contracts of what is happening on the blockchain. For example, if you've heard of OpenSea, OpenSea is an example of such a website. So you can go to OpenSea and show this. OpenSea is a very popular NFT marketplace. And this is an example of a website that is connecting to data on the blockchain because it's showing NFTs and it even allows you to buy, sell, and create them. And the website is kind of like the user interface so that anyone can easily create these kinds of tokens without having to do any coding. So that is how you can view a website on a smart contract. You actually connect the front end, which is just what you actually see on the page. You connect it with code to the behind the scenes where instead of using traditional web server database, you're using the blockchain to replace or to be a second layer or addition to your web server, your database. So there's a lot more that goes into it, very technical. So that's why we do have a whole other course all about how to view websites connected to contracts. We also have another question from Tito. Can you destroy a smart contract for whatever reason? If so, how? Okay, great question. If you write in the code of your contract that you can terminate it, then in theory, you would be able to destroy it in that way. You'd be able to close the actions. Like if you wanted to have a store that only opened from 8 a.m. to 5 p.m., you could write that functionality in the code to set the limits. However, you cannot actually remove it from the blockchain. You could send the ownership of the contract to the garbage address on a blockchain, which just means kind of like the address that nobody owns, so you can never access it again. But again, that wouldn't actually remove the contract from the blockchain. So I want to say no, you cannot destroy a contract because you cannot actually permanently remove anything from the blockchain. But it does depend on the code you wrote. So if you wanted to close your store, you could write the functionality for that to enable that feature. Kind of like how with cryptocurrencies, if you wanted to throw away all your Bitcoin for whatever reason, you would send it to Bitcoin's garbage address, which means, let's say I have 100 Bitcoin. I'm taking my 100 Bitcoin and I'm sending it to the address, kind of like sending it to a friend. But this is a friend that no one owns. So it's like sending it to the garbage can because once you send it to the garbage address, no one can ever reach it again. So I wouldn't recommend that, obviously, because you can never get your Bitcoin back. But that is kind of how we can destroy things on a blockchain, by writing the functionality in the code or by sending things to the garbage address. But you can never actually take anything off or just make the code eat itself. It doesn't happen. Once the code is put to a block, once any data, whether it's some text that you sent to the contract just to say hi, if the contract allows people to talk to it, if it's a chat contract, once you send that text, once you send the image, once you send the code to the blockchain, any kind of interaction, once you do it, you can never destroy it. Yes, the garbage is it's a public address because, yes, it is publicly available for anyone to send anything to. It's just 0x with 40 zeros after on Ethereum. However, no one has access to the account. It was specifically designed as a garbage address in the code for Ethereum itself. So you do have a lot of control over your contracts as the developers. We'll see that when we build them together in the summer, because you can write functionality. Do you want specific limits on who can use the contract? Maybe if you want one just for your friends, you could set that only these 10 specific addresses can use the contract. You can set that nothing of the contract will function until next year. You could set those kinds of time limits even. So you do have a lot of flexibility of the functionality and the limitations of contracts. Complexity, like you could build a contract that just says hello and that's it, and anyone who goes to it will just see that it stores the piece of text hello. Or you can build something much more complex, like a whole business with all of its systems, like a whole e-commerce shop or a whole school, or even clone YouTube in the form of a contract. And the reason you would do that is, again, to take advantage of all the benefits of the technology itself, because when you write something in a contract form, it automatically functions differently from just a traditional technology. Because traditional technologies are centralized, so they're owned by companies, highly controlled. Something like Google, they have a lot of control, a lot of power, especially with what they can track, the data they store, and how they can hide it. But the whole point of decentralization is to be a completely different way of running processes. You could even make a search engine contract. Tito's asking, is there a framework in Solidity to write smart contracts? Well, there is traditional setups for how you are expected to write contracts. So actually in the next slide, we have one example. This is a very simple contract for a basic NFT with just names and symbols, not even any media. Of course, contracts can get into multiple files, very complex, but it's just a basic example. There are also frameworks in the sense that there are standards for how contracts are expected to be written. These are called the ERC standards. Perhaps I can send you a link. ERC standards for contracts. Let's see here. Officially created by Ethereum itself. So I can drop a link to that in the chat. So these standards, they were designed to make kind of like templates or frameworks for how different types of contracts are expected to be made so that they function properly. And this is based on the most popular use cases for contracts. For example, something like a cryptocurrency token, very popular type of contract. Something like an NFT, very popular type of contract as well. Because they're so popular, these standards were designed kind of like a template to make sure you're not missing anything, to make sure you're building it correctly. And as we have more and more use cases popping up, we'll have more standards for different types of contracts. So yes, in terms of frameworks, I would look into the token standards. And a token just means a representation of something, some asset or entity on the blockchain. So token standards. We will be looking into token standards in the summer because we have to follow them if we want to make sure our projects work correctly. You don't have to follow them, but it's highly recommended. It just makes your life a lot easier. For example, if I'm building my own coin, I want to make sure that it can function on different places where people commonly go to buy and sell. Same thing with NFTs. I want to make sure my NFT is going to function properly on different NFT marketplaces. So to make sure you're not missing anything, you don't have any security gaps, to help you keep in mind all those potential security gaps and just functionality gaps. That's why we use standards as a template. Great question. Speaking of, next let's talk about cryptos and NFTs. These are the two ways that blockchain really got popularized, but you'll see in the summer that you can actually do a lot more. Contracts can get very complex, especially if you get hired at a company that wants you to build a contract to run some specific process on the blockchain. You're essentially a software developer writing contracts because you're building a system with code, kind of like how when you build a website, you're building a system that is running with code for whatever the website is designed to do. Same thing with contracts. As blockchain programmers, we're just going to be writing systems with code and putting them on a blockchain. Tito's asking, tokens in AI are of the same type as Ethereum and Bitcoins. Let's see. Not sure I understand the question. So a token is just used to represent any asset or entity on a blockchain. It's not necessarily a cryptocurrency token. All right, so let's talk about cryptocurrencies and NFTs. Feel free to clarify any questions in the chat. So we will be building a couple projects about cryptos, NFTs in the course because they are so popular, but we will go beyond that and make other contracts as well for different industry cases. But cryptocurrency was invented in 2008 with the invention of the Bitcoin blockchain. First cryptocurrency was the Bitcoin cryptocurrency. This was actually a very revolutionary technology because it actually solved a complex problem in the computer science field. And this was called the double spending problem, which we still have with traditional currencies, traditional digital currencies, but we don't have it with cryptocurrencies. So double spending refers to spending the same coin or dollar twice, which is essentially counterfeiting it or cloning it. This is a huge problem with the digital dollar or digital currencies because the nature of software, traditional software, makes it very easy to double spend currency if you're a hacker or if you're someone performing fraudulent transactions. But comparatively, it's much harder to do the same thing, to counterfeit a cryptocurrency. It's nearly impossible to counterfeit or do fraudulent transactions with cryptocurrencies. In terms of trying to copy a Bitcoin or trying to spend more Bitcoin than you have or trying to spend the same Bitcoin in multiple locations. It's much harder to do that than compared to something like, a credit card or just a digital dollar because of the cryptographic nature of cryptocurrencies. It's even in the name. So what does this mean, the cryptographic nature? Well, a cryptocurrency is a digital currency like a dollar. However, it's secured by cryptography. It's secured by the cryptography of the blockchain that it runs on. For example, the Bitcoin currency is secured by the Bitcoin blockchain. The Ether cryptocurrency is secured by Ethereum. ADA is secured by Cardano. If you have your own coin, it's secured by whatever blockchain you made it on. Now, how does that work? Well, at the base level, the blockchain tracks the ownership of a coin or fraction of a coin at all times. And depending on the blockchain, you could even go back and see who owned it at any point in history, the history of the blockchain since it was born. And so this is one way that we have cryptography in blockchains, because the cryptocurrencies are tracked in terms of ownership. So if you try to spend a coin that's not yours, before you try to spend it, blockchain will recognize that you are trying to spend a coin that you don't have ownership for. So the blockchain will kick back, meaning that it will not allow, it will reject the transaction. Now, as well, transactions are validated and encrypted before they get added to the blockchain. So this is also part of the security, the cryptography. So it's a whole other field, cryptography, and that's more into blockchain design and how different blockchains do their own cryptography and how they check transactions, because it does vary depending on the blockchain. But essentially, all cryptocurrencies are the same in that they're digital currencies that are tracked by the blockchain that they're on. And the way that they're tracked on blockchains was revolutionary because it solved the double spending problem. We do not have the double spending problem with cryptos, but we still do have it with digital dollars. So this was very exciting and revolutionary back in 2008. So some examples of cryptocurrencies, we've talked about Bitcoin, Ether, ADA, Solcoin. So there are many, many cryptocurrencies out there. There is a difference between cryptocurrencies and cryptocurrency tokens. So a cryptocurrency is sometimes called a native cryptocurrency because it is tied directly to a blockchain, meaning it's used to pay the gas fees of the blockchain. Like Bitcoin is the native currency of the Bitcoin blockchain. Ether is the native currency of the Ethereum blockchain. Now, you can also build cryptocurrency tokens on top of that. You can build tokens that represent your own cryptocurrency on top of existing blockchains. However, your token will never be used to pay the gas fees. So it's not a native cryptocurrency. It's built on top. People have to buy it with the native cryptocurrency. And then they can use it wherever it has value, or just own it for the value itself. So there is this slight distinction between native cryptocurrencies and cryptocurrency tokens. It's much easier to build a cryptocurrency token because all you have to do is write a smart contract for what the token is. Does it have any features or functionality? Does it have, for example, a limit time that you can buy and sell it? And then you publish your smart contract. You can control in the contract the limitations, the access to your token. Like, for example, will there be a limit of the number of tokens that will exist, or will new ones be generated every day? Or is there only 100 that will ever be allowed to be created? If you want to create your own native cryptocurrency, you would have to technically build your own blockchain, and then that cryptocurrency would be used to pay the gas fees of your blockchain. And you could do that if you wanted to, because blockchains are open source, like Bitcoin, Ethereum, which means you could create a clone of it and just change the name. You could change any features of it if you wanted to, if you had the programming knowledge, or you could just clone it directly. So that is a slight distinction between native cryptocurrencies and cryptocurrency tokens. Now, there are other types of tokens because, as I mentioned before, tokens just represent something. Like a cryptocurrency token represents digital currency. There's also NFTs, which stand for non-fungible tokens, also very popular. And these are used to represent some asset that has unique representation or distinction. For example, something like rights or ownership. Like if I wanted to sell ownership of digital land in the metaverse, Well, each plot of land is technically a distinct unit. And for example, 1, 1, 1, 2, 1, 3, 1, 4. And so to represent distinct units like that, we use non-fungible tokens. Because in my digital virtual land, I don't want someone to come to my plot. I want my plot to be unique. And there are other token types out there. As we see more development in the space, we see more use cases. So we see new types of tokens being created. But these are the two most popular types of token, or most popular type of thing that is created on the blockchain, and that is cryptocurrencies and NFTs. So NFTs could just be a unique piece of media. We see that a lot, but it could also represent voting rights, where each NFT is a vote, or it could represent ownership of some unique asset, which could be tied to some digital asset like the virtual land or some real world asset, or it could just stand on its own and not be tied to anything else. So a lot of information tonight. We will be covering all of this in more detail with project examples in our summer semester. We will get hands-on building a bunch of examples that we've talked about tonight. So you'll have much higher understanding when we actually start writing the code together. But hopefully tonight you got excited about what's possible. And then in the summer, we're actually going to be building some of these projects. So you'll have a diverse portfolio by the end. Here's a link to the course page. Feel free to visit at lumiwealth.com. I'll drop a link in the chat. We will be starting the course soon, our next live semester, so please sign up. We are also adding AI to the course this semester, which is very exciting. We're bringing in ChatGPT as kind of a bonus section towards the end of the course. How can we use AI to help us with blockchain development? For example, you can automate generating of content and code, and you can also automate generating media, which is especially useful for NFTs. So very exciting to bring AI this summer. We haven't done that before, so I'm excited to bring a fresh spin on the course and learn some automation. Now you can read all 8 weeks curriculum here on the course page as well. See a couple project ideas, project samples. We have 3 different plans for the course, 3 different ways you can take it: self-directed, live classes, and project help or tutoring. So you can choose which plan works best for you. Just add the plan to your cart. If it's a live classes one, then select that down here. The live classes meets for 8 weeks, excluding holiday breaks. We meet every Thursday at 8 p.m. Eastern, which is 5 p.m. Pacific, just like we met tonight. We meet for 2 hours per week live over Zoom. If you meet live, then you can ask questions, you can screen share, you can problem solve live with all the other students and your instructors. So if you sign up today, you can already get started by watching back our previous videos, because we have run about a year's worth of videos already, and you can also see the projects, the code. So as soon as you add items to your cart, you can proceed to your checkout. You can pay immediately or pay with a payment plan. And as soon as you enroll, you'll already have access to our whole library. So that's what makes Lumiwealth unique, is we give you past, present, and future. So you are a student for life. Whereas at a university, you would just get the 1 semester, but here we give you all semesters, so you can start watching today. And then you can join me once our summer semester begins live. Thanks everyone for watching tonight. If you have any other questions, you can book a call with us or email us. I'll drop our email in the chat. You can also message us on Discord or on Circle. So I can drop a link to book a call with us as well if you want to chat one-on-one over the phone. See here at lumiwealth.com/book a call. Be happy to answer any other questions you might have, so feel free. If you have questions about the course or about payments or what we'll cover, then feel free to ask. Thanks so much for joining me tonight. Check out our other webinars coming up next week. And if we have no further questions, then we can head out. Thanks so much for watching, everyone. If you do have questions, feel free to reach out anytime. I had a great time with you all tonight, and I'll see you in the summer semester. Don't forget to check out Web3 for all you web developers out there as well. And we'll be posting this recording on Circle at lumiwealth.circle.so, and we will be posting it on YouTube as well. Thank you all. Great questions tonight. Happy to answer as usual. All right, see you all in the summer. Have a great night.